So the topic giant covalent structure. This was a past week homework. If you have a doubt in any question or any part, you can let me know. Question number one. Any doubt? Question number one. Question one. Any
Yes,
doubt?
sir.
Okay. So question number one, silicon has the same type of a molecular structure as diamond. So if you recall the structure of a diamond, the diamond, each carbon form four covalent bond, and it is a giant structure, tetrahedral. So that is the structure of the diamond, how the carbon atoms are arranged in the diamond. The question is explain why one atom of either element can form four covalent bond. Like what is the reason why an atom can form four covalent bond? So what is the reason for that? The reason is because if you see silicon and carbon, because silicon and the carbon, they both belongs to group 4. As it belongs to group 4, it means they have 4 valence electrons, or there are 4 last shell electrons or valence electrons, you can also say. So it requires 4 more electrons to complete octet, or we can also say stable shell or a noble gas configuration. When we use the term noble gas, it means the shell is complete. That's what we call a noble gas. So because the silicon and the carbon both have 4 electrons and they need 4 more to be stable, that's why it is sharing 4 covalent bonds, or it is forming 4 covalent bonds, sharing 4 electrons or forming 4 covalent bonds. Then predict 2 physical properties. So they give you the answer. They mention it has the same structure as diamond. So what are the physical properties of the diamond? Same properties are there for silicon. Like what are the physical properties of the diamond? We say diamond is hard. So we can also say silicon will also be hard. Diamond is having a high melting or a boiling point. So we'll also say silicon will also have high melting and boiling point. Diamond does not conduct electricity. Same thing we'll say. It's not a good conductor of electricity. Diamond is insoluble in water. We'll also say it is insoluble. But that is what we need, a physical property. So instead of referring solubility, I don't advise to refer solubility. Just mention hardness, or melting point, or conductivity. So you can say it is hard, and you can also say it has a high melting point. Name a different element that has a similar structure and properties of silicon.
Germanium.
So what we have, yeah, you have to check the group 4 element, any of a group 4 element. Germanium
Diamond.
is right. Carbon will be acceptable, but they already, because they mentioned here diamond, so yes, they do accept carbon as well. So you can say carbon, you can say germanium. You can say carbon, you can say germanium, both are acceptable. Which bonds are soluble? Ionic compounds are water soluble. Ionic compound dissolve in water, but not even all. Yes.
Covalent and metallic aren't soluble, yeah?
Covalent, metallic are not soluble. Only ionic, and even not all ionic, most of them are, but not all of them.
So how we will identify whether the ionic compound is soluble or not?
There was a solubility table in the beginning, like most nitrates are soluble. That you will learn in topic salt, acid, alkali, and salt. That most all nitrates are soluble, most chloride, most sulfate. So there's a table, there's a full table for that. You will learn about the solubilities. Question 2, any doubt? 2 part A, B. A, B, C. Any doubt?
So 2A.
Question 2A, the element germanium has a diamond type structure. So they give you the hint that it has a structure same like diamond. Describe the structure of germanium. A diagram is acceptable. So either you describe in a description, if they ask us to describe the structure of germanium, is same like, so we'll say each germanium atom will form 4 covalent bond and it will be a giant structure. Or we can also draw, like if you draw for carbon, the diamond, I mean, because carbon can be graphite or it can be diamond. So when we draw the germanium, this is what we will draw. And the explanation, each germanium form 4 bonds or 4 covalent bonds, and it has a giant structure. Giant or a macromolecular structure. You can say state that as well.
So
But-
should we state like we have to draw the
No, no.
diagram as well as
If you
state the
if
answer?
you draw a diagram, then you will score the mark. If drawing a diagram shows 4 electron and it looks like a giant structure, you like 1 mark is for drawing these 4 bonds, okay, and 1 mark is for showing a repetition in the structure. So if you draw the diagram and you don't write anything, you will score the mark because they mention a diagram is acceptable. Question 3, any doubts? Any doubt in question 3? No doubts? Okay. Question 4, any doubt? Question 4. Can you again show the structure of germanium? Okay. That is what you should draw. Same like a structure of a diamond. Yeah, 1 germanium bonded with 4. Because group 4 element, it will always be structured like this. Question 4, any doubt? No doubt. Question 5. In question 5, you have to state why ionic compound does not conduct electricity in a solid state because ions are not free to move. Why it can conduct electricity in liquid state because ions become free to move. For a metal, why it can conduct electricity in a solid because electrons are free to move. Or in a molten also electrons are free to move. But in a giant covalent structure, we'll say it has no ions, no electrons. Here also, we'll say no ions and no electrons. So ionic compound does not conduct electricity in solid because ions are there but not free to move. Can conduct electricity in a molten state because ions become free to move. Metallic, it contains electrons and electrons are free to move in both solid or molten state. But for giant covalent, there are no free electrons or ions. You have to use the term both. Like no electrons and ions to move. That's why it cannot conduct electricity. Question 6. Any doubts?
Yes, sir. Can you explain?
Okay. In question 6, the first 3 elements of the group 4 are carbon, silicon, and germanium, and they all have the similar structure. The element and their compounds have the similar properties. The compound silicon carbide has a macromolecular structure similar to that of a diamond. Like when silicon combined with carbon, we call that as a silicon carbide, and it has the same structure as a diamond. A major use of a silicon carbide is to reinforce aluminum alloy, which are used in the construction of the spacecraft, like the airplanes or the spacecraft consist of this alloy, which is reinforced. Aluminum alloy is there, which is reinforced by a silicon carbide. Suggest 3 physical properties. The answer is actually given in the question. They mention that the silicon carbide has a molecular structure similar to that of diamond. So what are the properties of the diamond? Same properties are there for silicon carbide. So what are the properties of the diamond? We say diamond is having a high melting point. So it means the silicon carbide will also have a high melting point. We'll say the diamond is a hard substance, so silicon carbide will also be hard. Same thing, high melting point. This will also have a high melting point, or it will be strong. So the properties which we'll list here: hard, high melting point,
Can't conduct electricity.
does not conduct electricity, or we can also say strong material is there, does not conduct electricity, is fine. The next part, complete the following description of the structure of a silicon carbide. Look, silicon belongs to group 4, so it will form 4 bonds. Carbon belongs to group 4, it will also form 4 bonds. So each carbon atom is bonded to 4, which atom? Silicon atoms. And each silicon atom is bonded with 4 carbon atoms. Like, because look, carbon can form 4 bonds, so carbon is forming 4 bonds with silicon. And then each silicon is forming 4 bonds with a carbon. Because it belongs to group 4, so when element belongs to group 4, it will form. This is the structure of a silicon carbide, which I drew here. And then we continue, the repetition will be there, the silicons, and then the carbon. The repetition is there. Like silicon, carbon, and so on. 1 carbon, 4 silicon, then 1 silicon, 4 carbon around it. Germanium oxide has the same molecular structure as silicon 4 oxide. So look, what is the structure of a silicon 4 oxide? Each silicon forming 4 bond with oxygen, and then again there will be a silicon forming 4 bond with oxygen. Like bonded with 4 oxygen, not 4 bond, bonded with 4 oxygen. So this is the structure of silicon, but we want to draw germanium oxide. So instead of silicon, we'll draw germanium and draw in the same manner. So that will be the same structure. We don't have to draw silicon oxide. We have to draw germanium oxide. So all the silicons will be replaced by the germanium. Question 7, any doubt? Question 7. Any doubt in question 7? Question 8, any doubt? No doubt. Question 9. Any doubt in question 9? No doubt in question 9? Okay, so remember, just one question student asked. Look, when you talk about ionic compounds, ionic compound contain ions, but in a solid, the ions are there but not free to move. In molten state, there are ions and they become free to move. Here, not free to move. Metallic contain electrons in a solid state can move. Metallic contain electrons in the molten, also it's free to move. But covalent does not have, no electrons are there or no ions are there. That's why the covalent cannot conduct electricity at all. So this was a weekly, yes.
What would be the reason for the conduction of electricity of graphite?
Graphite is exceptional. Graphite has a layer structure in which actually carbon belongs to group 4, so each carbon should form 4 covalent bond. But in a graphite, what happened? Each carbon is forming 3 covalent bond, so there is 1 free electron available. And that free electron which is available is responsible for conduction in the graphite. So graphite, the reason, even though it has a giant structure, it is a giant covalent structure. But the thing is, carbon, instead of forming 4 bonds, it is forming 3 bonds. And because of the 3 bonds in the structure, 1 electron is free and that electron is helping in conduction. So there's a free or the delocalized electron in the structure of the carbon in the graphite. Because the carbon is forming 3 bonds, that's why graphite is a good conductor compared to that of diamond or silicon 4 oxide. Is it clear?